Okay, so I made up this little model to help you guys understand like post-tensioning. Here's a little just plastics is going to be so we can see through it. These are the ducts before you add the cabling into it. But notice how you can change their position. Now also notice as you rotate in this design, it puts it closer to one wall or the other. That matters also. As you can see, it would create a bending moment. If this was laid in that direction and you tension this, it's going to try to straighten out in this fashion. The tension the resistance, the load bearing capacity will be changed on this cable. The direction, the way its moment is, the way it's going to resist. So it's really critical that you get these post-tension ducts in line exactly the way you want the cables. As you can see now, as you would tension, I'm going to show you this part in stages, but let me I don't want to jump yet. So as this is encapsulated, encased in concrete, it can't move up. As you see now, it can't move up. I can move up now, but as the concrete is placed in it, I'm going to use plaster for this, it cannot move up. The cables get tensioned. It then has once it's pinned on each side, it then can resist. So as load is applied to the top of the concrete, it also has to create a compression for it to fail. It's got to compress the concrete, which puts it back, the concrete, in its strongest position, which it works great under compression, not tension. Tension is when it's mostly a load up top, and it's trying to create a V, if you will, down here and break open. That's the basics of it. So the closer this is to the bottom, you can see now that you can also create a problem where there's not enough cover on this for this to work, but that it's a whole lot of dynamics. Now you can change the position. Look at the bottom one. As I pull it up, it's now just a straight cable, a straight piece of steel, if you will. It does have it's more acting like a I don't want to say rebar, that's pre-tensioning. It's more acting like it's not as effective, if you will. If you have a little bit of bow in it, you can change the moment also. So if you've got a serious column up here, a load on top of this, you can decide to compensate for that by, you can crown this thing, you can run it straight. You have to figure out the vector on it, what's going to work the best for you. Again, though, got to be careful that this is in line and not doing this, or you're going to create you can create some positive and negative moments, some turns in this column to help create buckling, if you will. All right, let me put plaster in this and let's go from there. And you can see all the combinations you can do based on what you predict the loads to be. This would not be a good load for the top. That would actually be helping it straighten out, except for this is a crown. This is a good load if you can pre-tension it and get this whole concrete to flex like that ahead of time. Camber. Let's rotate again, and let's put some concrete in this guy. Mortar. What we're going to call mortar, plaster.